And today's webinar is a showcase of prefabricated bridges from the Alliance fabricators and manufacturing firms. But first, I also think that you should be aware of that simple design tool, eSpan 140. So I have just a couple slides on that. When we're going to consider both steel and concrete for a bridge project, we need an easy method to produce a preliminary steel bridge design for comparison to concrete. One of the objectives of the Short Span Alliance was to develop standard, simple span, rolled beam, and plate girder bridge designs. For plate girder designs, the solution will produce homogeneous girders where the web and flanges are built from 50 KSI material. For rolled beam bridges, the solution gives both a lightest weight design and a limited depth design. Because when replacing an existing bridge, many times a smaller depth is more economical overall, even though the steel weight is a little heavier, because with the smaller depth, existing approaches do not need to be changed. With eSpan 140, an owner or an engineer can produce a steel bridge design in just a few minutes that meets all the AASHTO requirements. The standard designs use common rolled beam and plate sizes and simple details for economy. The designs are for span lengths from 20 feet to 140 feet in 5-foot increments, and 4 different girder spacings are considered. The standard designs give the engineer the girder design, including fabrication details, shear stud and stiffener layouts, cross frame design, the deck design, and the end bearing designs. eSpan 140 is a free resource, and the best way to see if it could help you is to try it out. Just go to the website and try it out with a past or even a present bridge project. So now, coming back to the prefabricated bridge case studies, when we talk about manufacturer bridge firms, in the context of this presentation, prefabricated bridges are structures that are designed and fabricated by these manufacturing firms and delivered to the site ready for erection. Some people call them pre-engineered bridges, but that is not entirely true since each bridge is individually designed and fabricated for the particular site and load characteristics. The bridge is built into components or modules and assemblies in a quality-controlled shop, shipped to the bridge site, and erected. This results in time savings for construction, cost savings, increased site safety, and the pieces will fit together well because of the quality shop fabrication. However, another way to think of manufactured bridges is that they are a bridge in a box, and that the manufacturer has worked out all the design and details, sent it to the site, and the owner gets an aesthetically pleasing bridge without having the inconvenience of going through a typical design bid build process. Now for the showcase of manufacturing firm bridges with some traditionally fabricated accelerated bridge construction bridges. We're going to start with the Bouquet Street Bridge in Gibson, Louisiana. That replaced a 5-span concrete deck bridge supported on piles that was constructed in 1962. The prefabricated panel beam bridge replacement was 90-foot long with 2 12-foot travel lanes. Acro out of Parsippany, New Jersey fabricates standard 6-foot wide panels that are placed side by side for variable width bridges. For the Bouquet Street Bridge, the panels were shipped to the site and Gray Contracting erected the bridge. The standard bridges are fabricated for quick installation with minimal labor and no field welding, or field cutting, or field fabrication. The bridge modules are fabricated with pairs of girders, here with a steel orthotropic deck that had a factory-applied epoxy aggregate non-skid surface. All of the steel was galvanized for long-term protection. The modules were shipped to the site and set on the quick installation and no concrete curing time. Then the guardrails were bolted to the exterior girder. This Acro prefabricated panel bridge provides a simple design, quick installation, long-lasting life expectancy, while meeting and even exceeding AASHTO load and design requirements. The Bouquet Street Bridge, shown here, used an orthotropic deck with a steel guardrails, but the standard panel design can also use timber decking or cast-in-place concrete deck, and even Jersey-type barriers. Prefabricated modules are built in a shop, shipped to the site, and simply connected together for a good-looking quality bridge. A simple concept, combined with quality fabrication and practical erection planning, resulting in a great ABC bridge project. So that was the first one. Here's a traditionally fabricated rolled beam modular bridge built as a bridge replacement project for State Road 30 near Pittsburgh, Pennsylvania. The contractor was Brayman Construction out of Saxonburg, Pennsylvania, and the modular units were fabricated by Quality Bridge and Fab out of West Middlesex, Pennsylvania. The precast deck was cast onto the modular units by Brayman Precast. The project included demolition of the old structure, replacing the abutment stems and approach slabs, and constructing the superstructure with the modular units. The single span structure was replaced using accelerated bridge construction methods. Working 12-hour shifts, the old structure was removed and the new one installed in just 57 hours. The road was closed Friday after rush hour and open Monday morning before rush hour. Now, the beam sizes we see here are simple W30 by 99s that are 50-foot long with simple channel cross-frame diaphragms. The modular pairs were assembled and the deck was cast during fabrication. Then the modules were shipped to the site and set. And then the modules were connected together with ultra-high performance concrete. Now, here's our first video. This one does not have sound to it, so I will talk us through it, but here is the replacement of this bridge. So Friday night, they close the road and they come in and they start unstitching this bridge, the old bridge that they're replacing. And they tear that thing down, clean up the site a little bit. Now, it jumped a little bit, but here they are fixing those stem walls and starting to work on those approach slabs the next day. It started raining a little bit, didn't slow them down much, and now we're ready for that first modular unit, the end one that they bring in with a hydraulic crane, and they set it. All the while working on those approaches, here comes the second one. And now I wish they would have moved that hydraulic crane so we could see a little bit better, but they just keep putting those in and they're starting to do those closure pours with the ultra high performance concrete between the modular units. And they just keep bringing those in. And finally, that hydraulic crane brings in that final piece. So the bridge is set. They're doing the closure pours or fixing up those approach slabs. And we get to Monday morning and they open it up to traffic. With minimal disruption to traffic, the weekend, the old bridge was removed and the new bridge was ready for traffic in only 57 hours. That's a pretty impressive engineering feat. For another type of modular system, the Short Span Steel Bridge Alliance developed a new concept called the press brake tub girder. It is an economical steel bridge design that meets the needs for accelerated bridge construction. Now, the idea of tub girders has been around for a long time, but they are usually for larger structures with tub flanges and webs that are cut from plate and welded together. The idea of the press brake tub girder is that we take a standard width plate that comes from the mill and we bend it into the tub shape, maximizing its performance with no waste of steel material and no welding. The tub can be pre-topped with concrete deck, and the module is shipped to the site and assembled with ultra-high performance concrete closure pours like we just saw on the last one. Or the tubs can be set in precast deck panels installed. And several of these, many of these have been built across the country. Here are two press brake tub girder examples. The left bridge from Mercer County, Pennsylvania, shows a skewed bridge with precast deck panels placed on top of the erected tubs with openings in the deck for grouting the tub studs to make the bridge composite. The right bridge from Monroe County, Michigan, had precast decks on individual tubs prefabricated in the shop and shipped to the site. The modular units were placed and closure ports connecting the units completed the superstructure. These two bridges were both designed by Construct, which is now affiliated with Valmont. This press brake tub girder bridge that we're going to look at is a replacement project in Muskegon County, Ohio, and it's a little bit different. This bridge is special because the tubs are composite with a steel sandwich plate deck system that is only 2 inches thick. The result is a low-profile bridge that did not require extensive approach road work, even though they were increasing the hydraulic opening for the crossing. The tubs were bent in a press brake by Mako out of Ellsworth, Kansas, and fabricated by U.S. Bridge out of Canton, Ohio. Sandwich plate comes from SPS North America out of Banks, Oregon. And then the steel was galvanized and metallized for long performance by AZZ Galvanizing. So we start with a standard width plate from the mill, and we bend them into tub shape in a press brake. Then it's dipped and galvanized. The sandwich plate is only 2 inches thick, made from steel plates sandwiching a polyurethane elastomer core. That is then attached to the girders. Units are stacked on trucks and shipped to the site. And this video shows just how easy the bridge was to install on the abutments. Okay, don't blame me for the music at the background on these videos. What I've done is I've taken, of course, these firms' marketing videos and I've shortened them so that we can look at them here. So the bridge was erected from one side due to the light weight of the modules in only 20 minutes. There was excellent match fit and dimensional accuracy due to the shop fabrication and that sandwich plate quality. There was no concrete, so no curing time, and the bridge had immediate load carrying capacity. And of course, the locals appreciated just a 30-day road closure with the ABC modular bridge. Next, we're going to look at another prefabricated modular beam bridge with a cast-in-place concrete deck, a common erection technique from our bridge manufacturing firms. 2 beam elements are fabricated in the controlled conditions of a shop, shipped to the site, placed on the abutments, and connected together. This project is located in southern Indiana. The existing bridge was a narrow, deteriorating 2-span bridge with a total structural length of 35 feet. A 36-foot, 8-inch simple span prefabricated modular rolled girder superstructure was selected for the replacement, which we, of course, removed that center pier. The bridge modules were fabricated by Contech Engineered Solutions out of Westchester, Ohio, and the contractor was Civilcon. The new bridge was built with 3 modular sections that were shipped on 1 truck to the site. The modular sections consisted of 2 weathering steel rolled beams with a pre-attached corrugated metal deck. Simple bolted diaphragms connected the beam pair modules after they were set on the abutments. The concrete deck was cast in place and a galvanized steel railing finished the bridge. And this video shows the erection of this bridge. The superstructure package was designed and built so that the local county bridge crew could install the bridge. There was no contractor. Within 6 hours of delivery, the superstructure modules were installed and ready for deck reinforcement and concrete. Next, we're going to look at a buried steel bridge, which is kind of a combination of sub and superstructure. There are two kinds, corrugated steel pipe, which many of us call culverts, and corrugated steel plate, which is an arch-type structure with foundations at each end. This corrugated steel plate buried steel bridge was built on Route 2B in St. Johnsbury, Vermont. The bridge was fabricated and designed by Big R Bridge, which is now part of Contact, but they're in Greeley, Colorado, and built by J.P. Sicari. The bridge is located on a steep, narrow site on a curve with residents living nearby. There were poor soils on the site, so the designer needed a system that could accommodate significant differential settlement between the ends. Limiting the number of days the trail would be closed and constructing the bridge before the peak summer and fall seasons was a priority. The contractor had a maximum 50-day closure of the roadway, but earned a monetary incentive when it was reopened after only 45 days. The ABC project used precast concrete foundation blocks and precast wall panels to significantly shorten the construction time with no concrete curing times. The corrugated structural plates are shipped to the site and bolted together to make arches. Light equipment can be used to lift the arches, connecting them together across the width for stabilization, and then the bridge arch is covered with soil and the roadway built. This video shows how a single arch is lifted and placed on the foundations with light equipment, which is one of the benefits of these buried steel bridges. Now, I've sped this up 4 times since it is admittedly a pretty boring video, just watching a couple excavators pick up an arch, but it does show the simple way these bridges are put together. Yeah, not real exciting, but you do it with light equipment, local crews, and you can have yourself a bridge in just a matter of days. A buried steel bridge is lighter weight, flexible, and able to handle those anticipated settlements better than conventional bridges. With the lightweight structure, they were able to use those precast footings. Because of the arch, shorter spans are required to achieve the vertical clearance requirements. And there is a continuous road surface with no bridge deck or joints to maintain. And I like to show this one simply because I think they are just beautiful bridges. So here's another example of a modular rolled beam bridge, but this time for a rural road with a gravel riding surface. The existing Swamp Creek Bridge, located in Sweetgrass County, Montana, suffered from high water events and scouring issues. So 8-foot wide by 65-foot long twin beam modules were fabricated by True North Steel out of West Fargo, North Dakota, and the bridge was constructed by the local county crew again. The modules had a pre-installed guardrail and a corrugated metal deck for that gravel roadway. This bridge also used accelerated bridge construction abutments. True North's prefabricated steel box super sill abutments, an ABC abutment, were shipped to the site and installed prior to delivery of the bridge modules. Starting in the morning, the local county crew and a crane set the 3 8 by 65-foot bridge modules by lunchtime that same day. And here's a video of the Sweetgrass Bridge.
Swamp Creek Bridge for Sweetgrass County. It's a 24-foot wide by 65-foot span, pre-engineered modular steel bridge designed and fabricated by True North Steel. This particular job utilized the super sill abutment system, which is a steel box form that consists of structural elements, and once set and installed, is filled with concrete. The super sill abutment is typically utilized in situations where the soils are conducive for a perch style abutment or a spread footing. Modular steel bridges are simple to install based on showing up in component form and simply bolting adjacent modules together to achieve your width and length, and utilize a steel back wall to protect each end of the bridge and provides a decent place to build your road approaches. Turnor's steel modular bridges seamlessly tie together the most important aspects of bridges, including aesthetics, cost, and installation time. Our durable, prefabricated, high-quality modular designs are low cost and can meet AASHTO, state, and local bridge design requirements. We ship them prefabricated directly to the projects so they easily can be assembled and installed by contractors or county crews, resulting in minimal road closure time.
So yeah, that was definitely a marketing video, but it is a pretty cool bridge. In fact, I was just up in Whitman County, Washington, a few weeks ago, where we're documenting another True North bridge that's very similar to this one. And we're developing an education packet for the 3,000 counties across the US to show them how they can build their own bridges and save just tons of money. And that should be coming out next year. So back to this bridge, True North's bridge package was selected based on economics and the simplicity of the prefabricated modular design that could be placed on the abutments and bolted together. With a gravel riding surface on the corrugated steel deck, the bridge was open to traffic within a day and a half from when the first prefabricated bridge module was set. Now, several of the manufacturing firms have standardized truss designs that they prefabricate, package, and deliver to a bridge site. After Hurricane Maria in Puerto Rico, many crucial bridges were washed away and whole communities were isolated from civilization. U.S. Bridge has several standard prefabricated bridge designs that they ship, and they ship 5 of their Liberty bridges over a 6-week period, amounting to 800 metric tons of steel for over 950 foot of bridge length. This bridge is the Morovis Liberty Bridge, engineered and fabricated by U.S. Bridge and erected by the DeVal Group. The Liberty Bridge can be shipped as modules in containers, quickly assembled and erected, and can be used as a quality permanent bridge as they were in Puerto Rico. This particular bridge, out of the 5 sent, was a 24-foot wide, 3-span continuous truss with spans of 106, 98, and 106 feet, weighing 318 tons and shipped in 17 containers. The steel is galvanized for longevity and low maintenance. This video is rather short, but it shows the erection of a 3-span continuous truss, so I include it here. Yeah, pretty short video, but a cool video. I mean, it's just like they're building Tinker Toys out there. The truss parts and modules were shipped in containers to the site, sub-assemblies bolted together and lifted into place, and then a riding surface installed. The Morovis Liberty Bridge was constructed in 18 days. All 5 of the U.S. bridges sent to Puerto Rico were completed in 6 weeks. A local resident stated what helped us the most was the construction of the metal bridge. And that's true. Our manufacturing firms, with their innovative prefabricated bridge systems, can meet any bridge need and deliver bridge projects for owners. Here's one more modular rolled beam bridge, one that is a little larger in size than the others we have seen. Many of the manufacturers produce standard modular bridges, and these bridges are being built all across the country due to economy, quality, and ease and speed of construction. This Sevier River Bridge, located near Axtell, Utah, is a critical thoroughfare for the numerous farmers and ranchers in central Utah. The existing 1935 built bridge was structurally and functionally deficient and could no longer handle the load safely. The new 75-foot long bridge was built with modular rolled beam units using accelerated bridge construction techniques. The bridge modules were designed and prefabricated by Wheeler Bridge out of Minneapolis, Minnesota, and the contractor was Gerber Construction. The new bridge was designed with 4 longitudinal weathering steel beams. The beams were prefabricated in modular pairs at Wheeler and shipped to the site for quick erection. Simple bolted diaphragms connected the beam pairs after they were set on the abutments. Concrete deck was cast in place and a crash-tested prefabricated steel railing finished the bridge. And this video shows the erection of the severe bridge.
While it was on here unstrapping, we made sure our abutments were cleaned off, ready to go. We had laid them out to make sure that we knew where the beams were gonna sit. Picked it off, set it down on the ground to get our safety horizontal lifeline on there so we wouldn't have to get out on the beam. We got that in place, picked it up, swung it over. We set it into place where the beams were supposed to be. And we'll start getting these diaphragms. There's 4 diaphragm beams that we need to bolt onto the first sets of beams. We'll get those bolted into place. Then we will pick up the second set of beams and move it over towards the first set of beams to line up with those diaphragms. We'll set it down, mark the anchor holes on this one, then pick it back up, drill those sets of holes, clean those out, and then set it back into place and bolt the diaphragm beams up to the new section of beams.
According to the project engineer, we specified prefabricated steel on this project for several reasons. One reason was that steel beams are typically shallower than prefabricated pre-stressed concrete systems, which allowed us to keep a low bridge profile height. The second factor was cost. The prefabricated steel beams were less expensive than comparable prefabricated concrete systems. So this was a larger, traditional type rolled beam bridge that was modularized in design, planning, and erection techniques to meet an accelerated bridge construction need. So now our last case study demonstrates using construction techniques to meet accelerated bridge construction needs for a larger bridge. The Interstate 44 bridge over Gasconade River in Missouri is an excellent example of the lateral slide construction technique. The bridge is constructed next to the crossing and literally pushed into place to reduce road closure. The bridge was fabricated by DeLong's out of Jefferson City, Missouri, and installed by Emery Sapp & Sons. The composite steel plate girder bridge is 670 foot long with 6 spans, which is a very large bridge when you think of simply pushing it into place. Now, I could have more slides, but this video tells the story better than I could with words.
I remember the day we pulled up and looked at the job, I turned around and I asked Rusty and Chip, I said, you guys up for a challenge? I said, the way to do this project is build your existing bridge beside it, roll it in, and mitigate this whole river and all the flooding we have here. It overwhelms you at first, because it was a bridge of considerable length and a bridge of considerable height, and the tributaries down there you're working over, all that added together would give you reason to pause.
We've built a lot of bridges, so it wasn't so much erecting the bridge, but getting it from point A to point B. And being it's never been done in Missouri before, and I don't know how many times it's actually been done, period, but supposedly this was the largest bridge that's ever been slid.
We had Teflon bearing pads, a stainless steel plate that went from the temporary bent all the way across to the permanent bent. We used soap as a lubricant to actually allow the Teflon to slide on top of the stainless steel. And then on each pier, we had a hydraulic ram. There were 7 locations. Each one was synchronized to a central unit that actually controlled the hydraulics. It would push the bridge about a 2 foot, I think, and then the ram would actually pull itself forward, and then it would fall into 2 locking keys and then push against it, and it would continue that process until it got it into its final position 40 feet away. At the end of the day, when we actually got it in final position, we had our surveyors out on the project to check at each bent location at centerline. We had already previously marked where centerline should be. They went out and verified, and when we completed the push, the most we were off was 1/4 of an inch, and the least we were was as close as a thickness of a hair.
Once we moved the bridge over, and we knew we still had to tie in the roadway, but once that bridge slid over, I mean, the feeling was, it was pretty special.
All the risks that was associated with the project actually came true. We were able to show that. We eliminated the risk and still completed the project on time with several delays involved in the process, and still were able to hit the target date that MoDOT set out.
So there was a 20-day bridge closure for using the slide construction method compared to well over a 2-month closure that would be required for traditional construction methods. This is a 2,050-ton bridge where the slide took 10 hours, which is a really cool feat of engineering. And it's on a river. I used to fish this river when I lived in Missouri, so I know the area well. So to summarize, like I said in the beginning, we know that bridge designers, fabricators, erectors, and contractors have always been innovative in delivering bridge projects for owners. Bridge manufacturing firms can deliver high-quality, beautiful bridges that are economical due to economies of scale and efficient repeated fabrication practices. And traditional fabricators can produce prefabricated elements for accelerated bridge construction. Owners and design engineers can find more information on these prefabricated and manufactured fabricated bridges on the Short Span Steel Bridge website, shortspansteelbridges.org. If you need a bridge, these firms can design, fabricate, and deliver a bridge that meets your needs. And I encourage you to visit shortspansteelbridges.org, where you can find not only more information on these prefabricated and modular bridges, but also economical studies comparing steel and concrete bridges, including life cycle costing, information on all aspects of short span steel bridges, and the standard designs from ESPAN 140, so you can find a preliminary steel bridge design in just a matter of minutes. I thank you for joining today's SEANM webinar.